Need a dice roller that AI can actually use in your projects? We'll create a FastMCP server with a single tool that lets AI models roll any number of dice, returning the results as a clean list of integers. You'll see how to expose the function, handle the input, and make it instantly callable by AI assistants.
Import random. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dice roller. At MCP, tool. Def roll dice, end dice, int list int. Roll end dice, 6-sided dice and return the results. Return random, randint 1/6 for in range end dice. If name equals main. MCP, run.
This demonstrates the tool registration pattern for AI-augmented applications. The decorator-based approach transforms ordinary Python functions into callable tools that AI systems can discover and invoke, while preserving clean separation between business logic and integration concerns. What makes this distinctive is how it bridges the gap between human-readable code and machine-accessible capabilities without requiring transport-specific boilerplate. The pattern works by using decorators as declarative markers that signal tool availability to the framework. FastMCP handles the heavy lifting of schema generation from type hints, transport management, and runtime execution, while your code remains focused on core functionality. This creates a clean contract where implementation details stay isolated from the integration layer, enabling the same tool to work across different transports and clients. This approach matters because it dramatically reduces the friction of building AI-extensible systems. Instead of writing custom API layers or RPC handlers, you define tools as native Python functions and let the framework handle exposure. It's particularly valuable for rapid prototyping, internal tooling, or any scenario where you need to expose backend capabilities to AI systems without building dedicated interfaces. The trade-off is framework dependency, but the productivity gains often outweigh this for integration-heavy applications. Let's break it down line by line.
Import random.
This imports Python's built-in random module, which provides pseudorandom number generation. The roll dice function uses it to simulate dice rolls with random, randint.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI callable tools. It transforms Python functions into structured APIs that AI models can invoke, handling serialization and validation automatically.
MCP equals FastMCP. Name equals dice roller.
This instantiates the FastMCP server with the name dice roller, creating the central controller that will expose your Python functions as AI callable tools. The name parameter identifies this toolset in the MCP ecosystem, enabling proper routing and discovery by AI models. This is the required first step before registering any tools with decorators.
At MCP, tool. Def roll dice, end dice, int list int. Roll end dice, 6-sided dice and return the results.
The @MCP tool decorator exposes this function as an AI callable tool. FastMCP uses the type hints and docstring to auto-generate the tool schema, including parameter validation and return type enforcement. This is the standard pattern for defining tools in FastMCP. Decorator for exposure, type hints for validation, docstring for documentation.
Return random, randint 1/6 for in range end dice.
This is a list comprehension that generates end dice random integers between 1 and 6. It efficiently replaces a manual loop, creating the dice roll results in a single readable line. The underscore signals we're ignoring the loop variable since we only care about the iteration count.
if name equals main.
This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Without it, importing this file would accidentally start the FastMCP server.
MCP, run.
This starts the FastMCP server, exposing all decorated tools as AI callable endpoints. Without this, the decorated functions remain inactive, defeating the purpose of the @MCP tool decorators. Standard entry point pattern for FastMCP applications. FastMCP tool decorator pattern. The @MCP tool decorator transforms ordinary Python functions into AI callable endpoints, automatically generating schemas and handling type validation. Tool names in the decorator become the exposed API endpoints, so choose them carefully as they define the client-facing interface. This single decorator bridges the gap between your Python logic and AI model capabilities.
The decorator that names the tool becomes nameless to the client.